today we're going to do analytical interaction, continue with that, mainly talk about table calculations and also a level of detailed expressions. Okay. Now, in the meantime, if you notice, I've changed my location. As of a few days ago, I moved everything to my home instead of my office. So this is my current setup. This is what it looks like. Show you quickly. Right, so I do have a nice view. I have a beautiful garden, but at the same time, I actually am left with this portable table. Why? Because my wife and daughter have taken other tables at the home, so I'm stuck with this, and nonetheless, I'm happy. So there's no questions about that. All right, so today we're going to do analytical interaction and talk about a few more things in Tableau. And these things that we're going to talk about are kind of complex, but nonetheless, I want to expose you to these kind of complex topics as soon as possible. Okay? Now, so we talked about ways of interacting with a viz. We talked about re-expressing, revisualizing, rescaling. Okay? And we're going to talk about some of that a little bit more. Today we'll talk about filtering, aggregating, and re-expressing quite a bit. Okay? So we basically tried last time, how can we compare order numbers and population? And we said one way to do this is using expressions, right? Re-expressing by percentage of the total in the entire nation, right? Percentage of orders in any state as a percentage of the total sales, percentage of the population in any state as percentage of the total population. And this allows us to compare things, seemingly different variables, because they're both they're percentages, so we can actually compare them. Okay? We basically talked about last time sales and population rank, and we said, here is the sales rank for a state, and here is this population rank. Okay, so if you notice, California is doing well in sales, but it's also doing well in terms of population. So that means the sales is mostly due to its population, whereas Texas, as you notice, population is quite high in Texas. Right here it's 8, almost 9%, versus its sales is low. Okay, so we said let's see what is going on here, and we then said take a look at the differences, take a difference between sales and population, and then look at which states are doing well and which states are not doing well. Okay, so they're underperforming given their size. Okay? I'm going to specifically focus on Texas. Okay, right here. If you look at Texas, it looks like it doesn't place a lot of orders, okay, given its size. Now, the next thing I'm going to do is I'm going to look at this idea to see if Texas is really placing a lot of orders or not. To do this, I'm going to look at the orders population difference, and I'm going to compare it to sales population difference. Okay, so if you now notice, if you look at Texas, Texas actually is positive here, versus it's negative here. So that means Texas actually places a lot of orders, but it apparently doesn't create a lot of sales. So let's see what the reason for this is. So the question is, perhaps Texas orders are relatively small. So let's check this. And we said we can check this using, we can look at the comparison. We can look at actually the difference between the sales and orders. Okay, and we can see that Texas is right there at the top. Right, it's the #1 state, so that means they place a lot of orders, but they do not place they don't create a lot of dollar sales. Okay, so this is the difference between order percent and sales percent. Okay, and we did this last time. You have the worksheet already for this. Now, another way to see it is basket size. This is what we said. We said we can look at the basket size of orders from Texas. And we found out that the basket size, the average order size for Texas is 173. And last time I said this is actually wrong. And I'm going to tell you why this is wrong. And then we're going to see how we can fix this. Okay. So let me skip this. We have already done this. So we highlighted it, but we said this is wrong. Let me tell you what is wrong. If you look at the data, the source data, you will notice that for each order, there could be possibly multiple lines. Okay. So if you go back to, let me go to one of the go to data source, one of the files I posted, okay, and you'll see that in the data source, same order ID appears multiple times, right? So here's the order ID, this order ID appears twice, okay? So that means there are multiple lines. So when we do the calculation in Tableau, right? So what we are doing is actually, if there are multiple lines in each order, like this, we take these numbers and we find the average of all these numbers. So suppose these are Florida, right? So the average for Florida in this case will be, so it will be these three. So you take these three and divide by 3, okay? So that is 650 divided by 3, okay? So that will be the average sales for Florida, right? And for California, it will be 500 divided by 1. But this is not correct. What we want to find is average size of the order. So we have to actually treat these two numbers as one, okay, and make it an order, and then treat this as a separate order, and treat this as a separate order. So the overall average of my sales in this case will be 2850 versus if I calculate the basket properly, it will be 388, okay, 83. Now for Florida, of course, it will be the average of these two values. So it will be, if I correct this, so the green one, it will be the correct one. It will be divided by 650 divided by 2, okay, versus, in this case, for California, it doesn't change. But for Florida, you notice basket size goes from a small number to a large number. And this is always true. So if you treat each individual line as a specific order, your basket size will be underrepresented, okay? So especially if for those states where you have a lot of lines in those orders, their basket size will go down, okay? So what we need to do is we need to find a way so that we can recalculate. So we will recalculate each of these baskets separately and then find the orders, and based on the orders do the calculation, okay? So this is one major problem. But there are other problems that we have in our worksheet because the lines of orders are multiple, and for each state you have multiple lines. So if you look at our Tableau worksheet, this is from last section, the last file that we created, Analytical Interaction Examples 3. So this number is wrong, that we know already. What else is wrong is the following. So let's look at one of the worksheets. I'm going to look at orders per state. So this is number of orders placed in each state. So let's put the markers. I'm going to go to analysis and show mark labels. So you can see that 1,000 orders are from California, 560 from New York and Texas, and so on, okay? So let's, instead of looking at these numbers in absolute values, let's look at the relative values by dividing the total number of orders to the sum of the total number of orders, so that I can see each state, what percentage they produce, okay? Now, when you do this, you notice that in this case, I also have a filter for state. So here is the filter on the right side. So let me remove this filter so that we can add it again. So I'm going to remove it unless we can add it, okay? So I'm going to go ahead and first click on drag and drop state to the filter, okay? Now, as soon as I do this, it will show me which states I should have. So I'm going to choose all of them because I want to be able to filter by all. And then I go ahead and add the filter. So show the filter on the canvas. The next thing you notice is I'm going to actually uncheck some of these states. So I'm going to go to New York and uncheck this. I want you to watch the number for California. Now, you notice the number of California keeps changing as I remove the states, okay? So the percentage is actually what is the dimensions that you see on this worksheet, okay? So the dimensions you see on this worksheet are basically states and then only the available states. What if you don't want these numbers to change? So what if you want to say, so whatever this number is when you show all the states, you want this number to stay constant. We're going to talk about that as well, and that will be achieved using level of detail expressions. Okay. All right. So there are a bunch of problems that we have. Let's talk about these. So the percent total values will be based on the entire data set, and sometimes will be erroneous. Okay. And if you multiply a filter, apply to a filter to a worksheet, and these percentage values will change as we modify the filter. Okay. Average basket size, we set each line separate. We talked about this already. So this is an okay measure, but this is not really what basket is about. And let's see how we can fix these issues. And this will, of course, we're going to learn how to deal with Tableau as well. Okay. Now, we're going to use what is called a level of detail expressions, right? So even though it's easy to add filters, you got to be careful because there are sometimes caveats. So you need to really understand what's going on with your data. Okay. So we talked about this already. When you add filters, your calculation totals will change. And if you want them to stay based on all dimensions, not on the filter, but on the own dimensions, then you have to be really careful. Okay. So that's the idea. All dimensions. Okay. Or sub dimensions. And one way to do this, of course, you can create new measures in your Excel worksheet or database. But then it will be trouble. So instead of calculating these number of orders here, so you're going to go to your table and then go create these numbers and percentages in the table, just like we did earlier with this population percent in 2018. Same thing, we did this in the Excel, but you don't always have that. You don't have access to the database, you don't have access to the Excel file, source file, to change it, okay? But we're going to do it using LOD expressions. But before we do LOD expressions, let's talk about something called table calculations, okay? Now in Tableau, you can actually do table calculations. So if you do not have the values you need in the visualization, right, then you can use a basic expression to create it. If you do, then you can actually use a table calculation. Okay? So let's talk about basic expressions. What are basic expressions? So for instance, the profit ratio is a very basic expression that we're using. Okay, the sum of profit divided by sum of sales, and this is our profit ratio. All right, before getting to the basic expressions and creating few, let's go ahead and look at our class website. I made some changes and added some files to there. First of all, whatever you see from this point on, partly it's going to be on Analytical Interaction Examples 04. Okay. Now, if you look at the class website, I basically went ahead and released all the notes. These are the notes from my last semester. I'm going to make some changes, of course, as we go along. If we do, I'm going to post and perhaps let you know, and perhaps either I'm going to do it here during the presentation, or perhaps do it with an announcement. Okay. Now, one of the things I want you to note is in week 33, I actually posted your project description. So I want you to read this carefully before I talk about it next time. And so I also posted assignment 2. You're going to use this nations CSV file in assignment 2, and that is due in April 6th. You have quite a bit of time. What else is there? So I'm doing this lecture 5 analytical interaction, and then this is the file, analytical interaction files. I'm going to look at this. Okay, so let's look at this folder. So that folder, I have a version that I downloaded here. So let's see where it is. I think I must have closed it, so let me open it again. All right, so it's under my downloads. So if I look at this folder, this is the folder that you will have when you download. So I have a bunch of files. So the first 3 files are exactly the same as the files that we have. And then it comes Analytical Interaction Examples 3 fixed using LOD expression. I'm going to talk about this. And then there's a fixed version. There are 2 different ways of fixing it. And then the Analytical Interaction Examples 04. And we do also have, and the rest is pretty much the same files that I had before. And then I have this table calculation. So notice this table calculation LOD shell is an empty shell, and this is where we're going to do our calculations. So I'm going to go ahead and open that up. Takes quite a bit of time. All right, so it's just an empty shell of my data. So it's so that we have the exact same data. Now, one of the things you may notice that I think one of these was wrong there. Population percent, I guess this was wrong, or either one of these. And I fixed it, so I can show you what I did. I basically changed number 2018 to population 2018 because I had changed the attribute name. I think yours is wrong, so you can go ahead and change 2018. I'm going to explain this formula, but for now, if you don't want to see that red mark, change this 2018 in two places to population 2018. Okay, it's relatively easy to do. You can just right click on this, and we'll describe this, we'll work on this. You just go to edit, and there it's going to open up a screen like this, and we'll talk about how to fix these. Okay, so this is where you change it. Okay, so fix that if you don't want to deal with that red while we're doing this. Now, what else? Now, what you can do here is, we said you can actually go ahead and create expressions. So this expression is already there. If you look at profit ratio, it is already in there. So let's look at profit ratio. So let me get rid of this first of all. I don't need it in this screen. And then let's look at profit ratio. So if you look at profit ratio, I mentioned this before, right next to it on the left side, so this is a measure, pound means measure, so it's a numerical number. On the left side you have this equality, so that means this is a calculated field. So this basically, if you right click on this and click on describe, you'll see that it has this formula, exact same formula that I have. So sum of profit divided by sum of sales. So this is your profit ratio. Okay. So, and how do you create a calculated field? You basically, there are a couple of ways, but you can go to analysis and then click on create calculated field. Let's go ahead and do one. All right, so I'm going to go ahead and create a calculated field called, this is discount ratio. Okay. So this is the same thing that you have on your notes. Okay, so I'm going to go ahead, and here I can type any formula I want. So this is an if formula, IIF. And then I basically say, what is the formula? I say sales. If you type sales, you'll see that immediately it will pick up the right measure. So hit tab, so it gives you the sales properly. And if the sales is not equal to 0, I say take the sales, so discount, take the discount divided by sales. Okay, so this is my discount ratio compared to sales. Else it's 0, right? So if it is 0, I don't want to have a division by infinity. I'm going to close this. So this is my profit ratio function. Again, this is not case sensitive, so you don't have to worry about case sensitivity here. But of course, it picks up the column names, dimensions, or measures. Okay. So I'm clicking on OK. So now it gives me this new variable called discount ratio. I can go ahead and look at it. So this is my total discount ratio. Of course, this doesn't mean much. So I'm going to look at the average discount ratio. So let's make it average. The next thing I'm going to do is turn it into, go ahead and format this, and go ahead and make it a percentage. So the value is, so I'm going to have to look at, what did I do now? So I'm doing the box, so I don't want to do the box. I want to look at this number and change it. So I'm going to go ahead, click on the format. Again, so what am I doing wrong? Okay, so okay, let me click on this. Let's format it here. So I want to turn it into a percentage. Okay. So my average, so let me change this name now. So this is my discount ratio. Come on. All right. Now, once I have this is my average discount ratio. Next thing I can do is I can go ahead and look at it for each segment. So I can actually take the segment, drop it right here on the top, or I can go ahead and drop it in the column or row. Same thing. So I'm going to do rows now. So look at discount ratio across different segments. You see that it's not much different, almost. Okay. So how about if I go ahead and add, let me see, category. So let me get rid of this segment, throw it away. I'm going to go ahead and add category. So under the product, there has to be a category. So if I can find it right here, I'm going to add category. So look at the categories, there's a huge difference. So the furniture, office supplies, and technologies, there's a huge difference. I'm going to go further down, click on this, and I'm going to get subcategory. If you look at the subcategories though, you'll see that there is a huge difference. The furnishings in the furniture case is almost 90% discount. Okay? So it's almost like 1% discount, right? Not 90%. Okay? So appliances is 1.7%. Binders is 6%. Okay, so as you can see, there's a huge difference across various categories and subcategories. Right? So that's about it's very relatively simple. Okay, so you can do very nice expressions using just this analysis and create a calculated field, and you can use all kinds of functions there to calculate a new field based on the columns, okay, that you have. All right. Now we're going to use some of this later. I need for visualization. Then if the answer is no, then we use a basic expression. If the answer is yes, we can use a table calculation. Okay. There's one more question that we will ask. One is, does the granularity of the question match either the granularity of the visualization or granularity of the data source, right? So if so, I use a basic expression. If not, then I'm going to go ahead and actually use a level of detail expression, okay? Right? So if I have all the data I need, I just use a table calculation. If not, I have to create this either using a basic expression or using a level of detail expression. Okay? So remember, the granularity of the data was not at the granularity of our level. So when we have states and we're going to look at the average, let's say something on the states, it was not at that granularity, so it was not matching. So that's why we were getting those errors. Okay. So before we go into the level of details expressions, we're going to talk about table calculations. Now, read more about these table calculations. There are some examples there as well. I also want you to read and watch the videos for both table calculations and also for LOD expressions. Even though I'm going to do some of it here, it will be always a good idea to also watch the tutorials from the Tableau directly. Okay. All right. Before we get into the level of detail calculations, then to understand what they are, we have one other question to consider. Okay. So that question is this first question. So actually, when you choose what kind of calculations to do, what you're doing actually is the following. Right? So you first ask, does my question require ranking, recursion, moving calculations, or interrow or calculations to answer it? If the answer is yes, then you use table calculations. If the answer is no, and the next question is, do I already have all the data values I need for the visualization? If the answer is yes, you use a table calculation. If the answer is no, then you check the granularity. If the granularity doesn't match, then you go to the basic expression. Does match, you go to basic expression. If not, you go to level of detail expression. Right. So what is then level of detail? Now, so the level of detail is basically when you have a tableau, so you have certain places you can add dimensions. Okay, so all these red places in your tableau are where you can add your dimensions. Right? So, of course, this is not the same as your tables in your data source. It's different, right? So whatever dimensions you have is totally different than what dimensions you have in the original table. Okay, so some of these are called shelves, like these, and the others are called cards, okay, or pills or cards, okay. So these are places where you can put your categorical variables. So that kind of determines what is the level of detail. Sometimes this really doesn't match with the analysis. All right, let's now look at table calculations. Now, before we read the definitions, I want to go ahead and do a simple example, and then we're going to come back and look at these definitions. It will be much easier to follow, okay? All right, so let's take a look at this. So what I want to do is, I want to be able to create a table. So for sum of sales for various regions, segments, and categories. So what I want is, I want to take the region, put in my rows, and take the segment, right, and move it here as well. And then you notice I get more details. So these are my dimensions. And then I'm going to go ahead and add category. So here's the category. I'm going to add it there as well. And then what I'll do is I'm going to go ahead and take my sales and drop it on, I can drop it right here, or I can just drop it on the text. Okay. So this is basically for each region, for each segment and category, these are my sales. Now the next thing is I'm going to go ahead and create a table calculation. So when I click on the sum of sales, you see one of the things I can do is I can add a table calculation, or I can add a quick table calculation. So quick table calculation, I can look at the difference. So here it's going to start from the top, at the very top pane, right? And it's going to go and subtract each unit. Okay, so this is, if you go back, so 93,000 minus 86, 72 minus 93, that's exactly what I'm seeing here. So it's a difference from the first element. Now instead of this, what I can do is I can click here and go add a table calculation, and this is going to bring me out a nice interface. So what I can do is here I can actually decide, right? So I can take a difference, I can take a percent, I can take rank, I can do many of this. I can look at the rank, right? So this basically ranks everything from top to bottom and tells me exactly what the rank is. Okay, I can do a difference. So when I do the difference, so let's look at the difference, right? So let's do difference. So I can choose to decide whether the differences start from top and go all the way to the down, or it should do in each region. So what I do is I can choose table down. In this case, that's all I have. I can also do pane down. So if you look at the pane down, you notice in each pane, the result is going to reset, okay, right? So since I have only one row or one column, I cannot choose across and down, down and across. I'm going to do that in a short while, okay? For now, what I'm going to do is I'm going to change these specific dimensions. I'm going to say, don't do it by category, just do it by region. So it means each region, it was going to take a difference from the furniture all the way to the end of the region, but it's going to reset after the region. So that means the region is going to be the specific dimension that will be excluded. Okay, multiple columns. So what I'm going to do is actually I'm going to take the category and move it to the columns. So now I have, as you notice, I have each of these, right? So furniture category is here, and then the region and segment are on the rows, right? So if you look at the difference now, the difference now is for, it starts for each category. Okay, so for each category it starts from this corner, and let's go ahead and change this. So let's go ahead and go to table calculation again, right? So this, notice this is these specific dimensions. So I'm going to actually add all the dimensions and then do table down. Okay, so if you do table down now, you notice each row, the difference is reference to the first row of each column. Okay, if you do table across and down, and this is how it goes. Okay, it goes across and down, across and down. This is the differences. Okay, table down, then across, then it goes this way and this way and this way. Okay, so that's pretty straightforward. So you can do pane down. So you notice each pane, the differences are from the first row of each pane. Right? So it's relatively easy to work with, but you need to understand. Here I can actually go to specific dimensions again. So here it's down the segment level. So I can actually do it at the region level. You see that each region, okay? So I'm actually going from the corner of that region. So here is the region, these are regions, and that's basically how the differences are done. All right, so let me go back. What I'm going to do next is I'm going to look at something very interesting, right? So instead of these differences, what I'll do is I'm going to go ahead and change my table calculation. I'm going to go ahead and let me see. Right? So I'm going to change this from difference to make it percent of total, right? So this is my now, it's percent of total. So now if you look at it, so what is this total of? So if you select these, you'll see that it's going to be 100% in each region. Okay, so this is 100% in that region. Okay, right there, it's 100% in each region. You just select it and it will show you what the sum is. Okay, now what if I want this to be the entire table? So that's exactly what I will do. I'm going to go back to the table calculation again. Alright, so I'm going to view the table calculation, and this time I'm going to basically say do the whole table. So just table, it doesn't matter in this case. So I'm going to just table down, right? So table across means each row adds up to 100. Since I have one row, it's just one column, it's just one value. But if I do table, and this is what is going to happen, right? Now, the next thing I want to do is, if I want to add a filter to this. So if I go ahead and add filter to this, let's add region as a filter. So let's go ahead and find the region. Okay, so I'm going to drag region and add it as a filter. All right, add all 4 regions, and then go ahead and change, edit the filter. So show the filter. Now if I go ahead and remove one of these regions, let's say remove the west region, you notice these percentages will change, right? Because those percentages are based on the view. So the level of detail is the view that you're seeing. Okay, so this now adds up to 100%, even though I set the entire table. So this really doesn't show me this region, this consumer segment, and this furniture subcategory or category. It's 17% of this region, but not the entire population. Okay, so let me expand this a little bit. So what you need to do is, there are many ways of doing it, but for now I'm going to go ahead and change the formula here. So I'm going to change this part from total to this formula, ATTR. Okay, I'm going to explain this. So here for the sum, I'm going to create a level of detail expression, and they're always written in these curly brackets. So I'm going to go ahead and say fixed. Okay, so it's one of them. So I'm going to fix it, and then go ahead. So what I'm doing is I'm fixing it to the entire table, entire data source, whatever dimensions I have. Okay, I'm going to close this. Okay, so this is the level of detail expression, LOD, right in the middle. Okay, so all right, so I'm going to go ahead and hit enter. So what now happens is, so let me go format this quickly. So the data, let's make it percentage. Okay, so let's close it. So you now notice that the percentages are for the entire table. Now if I go ahead and remove one of the regions, you see, right, none of the values change. They're still the original values based on the entire fixed dimension of the table. So we call this level of detail. Okay, now we can also add, let's say, I'm going to go ahead and add, let's say, another attribute to the filter. So let's go ahead and add category. All right, and click OK, and go and show this filter too. Now if I filter one of the categories, let's do the category furniture. So you notice this whole thing is summation. It sums up to the 100, right? So now if I do it, remove one of the furniture categories. Okay, so notice now those numbers don't change either. Okay, so it's 405, right? So I'm going to remove this furniture. So let's look at it. So it's still 405. Okay, all right, so it's the entire table. All right, I can also fix it at the region level. So I can click on this and go edit, and I can go ahead and say fix, but this time I can actually add an attribute here. Choose region. Okay, so now it's going to fix it at the region level. So if you look at it in the region level, so now the region itself, each region sums up to 100. Okay, so now if I change the category furniture, right, you see now region will sum up to 100%. Oh, sorry, region will sum up to 100%, but the category that we removed will be removed from the view. Okay, so let's look at it this way again. So now the region sums up to 100%. Okay, and I'm going to go ahead and remove technology at the bottom. You'll see that numbers do not change in the category. So that now each region adds up to 100. So I'm fixing at the region level, not the entire table level. So I can actually add multiple attributes here in this level of detail expression. Now this is a rather complex level of detail expression. So let's start with a simple example. For that, I'm going to go to one of the examples. So, all right. So let's go ahead and do a new example so we can understand this complex formula with a little bit of ease. All right. Now, so to create, what we're going to do is we're going to create a calculated field. So in this calculated, we'll have this level of detail expression. In this case, we're going to include customer name and do sum of sales. So let's take a look at this. So what I want to do is go to my file. So let me go ahead and create a brand new one. So what I want is create a new calculated field. So let me calculate a new calculated field. Analysis, create a calculated field. Now we want this calculated field to be named, let's say, sales per customer. Right, so we want to calculate average sales per customer. Now for this, we're going to go ahead and write this. I'm going to say include, right? Customer name, right? So that means aggregate the total sales for each customer. So that's what I'm saying. I'm going to say sum, and then let's add the customer. This is the sales, right? So what this will do is it will create sum for each customer. At the customer level, it creates a sum. So when I go ahead and put it right here, so if I look at the average of this, right? So this is basically the average sales per customer. But you notice in my original data, I have the same customer appear many times. So let's look at the customer name. So this customer here appears many times. Perhaps it appears more. So what this does is it includes the customer name and sums up all the sales figures for this same customer, and then comes up with one figure. And that is exactly what this this value is. Okay. So if I go ahead and add customer name to this, so they go ahead and add a customer name, you're going to see that there is this one figure for each customer. So for each customer, there is this figure, and this level of calculated field calculates that. Okay. Now, if I go ahead and remove this, right, so let me remove that too. Right, so let me go ahead and remove this. So if I go ahead and take, let's say, for each region, look at the average sales per customer. So I'm going to go ahead and take each region. So here's my region. All right, I'm going to take the sales. So, right, and then go ahead and create a bar chart. Right. So let me turn this, make it vertical. So this is basically the total sales for each customer. So I'm going to go ahead and change it to average sales per customer. Right, and then let me add that to the label. I'm going to go ahead and say label. Okay. So let me go, I have to add it again. So I'm going to add it. And let's make this also average. Okay. So this is the average sales per customer. However, so let's look at these numbers. But this basically assumes each row independent, just like we did in the market basket case. So each customer sales is assumed to be a single value. So now I'm going to do the aggregate. So I'm going to go ahead and I'm going to add sales per customer. And again, I'm going to do the average. All right. So for each of these tables, I'm using average sales as the label. So I need to go ahead and remove this. Okay. Then go ahead and for each one I'm going to get different ones. So this is the average sales, so this will have the average sales as the label. Okay, so let's change it to average, and I'm going to go ahead and add sales per customer to the other pill. I'm going to go ahead and sales per customer again, do the average. Okay, so now you'll see that this is 796 versus 216. Okay, so this is the proper, gather all the customers, look at each one, calculate the sales, and then find the average. Okay, so that's what the correct value should be. Okay, so what we do is we use a level of detail expression, in this case an include, so the sales per customer. So that means every time there is average sales, I'm going to aggregate them based on the customer. So even though I don't have customer information here, you notice customer is always included in this calculation. So that's an include level of detail expression. Okay. Now let's look at types of level of detail expressions. So we have actually fixed, we have seen one example. We have include and we have also exclude. Okay, we're going to do an example of exclude a bit later. All right. So the include level of detail expression computes the values based on the dimension, specified dimension, whether that dimension is on the view or not. Okay. Excludes that dimension. So we're going to see an example of that. And here's an exclude example. So let's do that. So I'm going to create a new, new variable called exclude region, and I'm going to call this is the formula. Okay, so I'm going to go ahead and create. Right, I'm going to go ahead and add a new calculated field. I'm going to name this exclude region. Okay. And here's the formula. And then we're going to exclude region and then do sum of sales. Okay, and then let's close this. All right. So now what this will do is the following: use this new variable that we created, this exclude region. So for that I'm going to create a new chart. In this new chart we're going to go ahead and look at monthly sales. So I'll take the order date and drop it in the rows. And then I'm going to go ahead and change it to months so that I can have various months. I'm going to go ahead and then add the sales, right, for the columns, right? And I don't want it to be a line chart. I'm going to go ahead and change it to a bar chart. And the next thing I will do is I'll take the sales and put it as a label. Okay. Now I have monthly sales. I'm going to go ahead and actually change this order from the reverse order, so December all the way to January, right? So the next thing I want to do is I want to add category, one more category here, which is basically my region. So I'm going to go ahead and look at it from the region to region. So I'm going to put it right next to it so that it will create a new chart for each region. Once again, these are my total sales. So if I go ahead and look at the colors, I'm going to add now sales to the color. You'll see what it will do is it will create a scale, and the scale will be from the lowest sales to all the way till the highest sale. So the lowest sale will be the light blue, and then the highest sale will be dark blue. Of course, you can change these colors by clicking on this. But if I want each region to have its own color scheme, so I want the analysis to be fixed at the region level. So in that case, instead of using the sum sales to color, I can actually use this new variable that I created, exclude region. So what that will do is it will actually exclude region when it does this coloration. So in that case, you look at it in each region, the lowest value in that region will be the lightest blue, and the highest value will be the darkest blue. Okay, and then it will do it in each region. So that is the difference. All right. So it's quite useful. So using this level of detail expression and creating this new calculated field allows us to do this at this region, this level. Okay, so it allows you to kind of take a look at the dimensions here, but then exclude some of the dimensions when you do certain calculations. Okay? For level of detail expressions, this is the general syntax. So you have possibly three keywords: fixed, include, and exclude. After that, you have the dimension declaration. If this is empty, so that means this is the level of detail expression is at the table level. Okay, so we call it at a table level. So here is an example. So this is called table scope level. So there is no dimension. Right? Now, so you can have fixed, include, and exclude. So you can read more about them, and then you can watch the tutorials there as well. They have some good examples as well. And then what I want to do is I want to see how we can actually use these level of detail expressions and go ahead and fix some of the issues that we faced in our interaction examples. Okay, so here are the expressions, but before I do these expressions, I'm going to go ahead and look at those files once more. So I have two files here. One is analytical examples fixed, so I'm going to open that up first. All right. So in this one, what I did was I went ahead and I fixed the basket size. So I did not fix any of these because I'm using here the fixed version. So what I'm doing is I'm using this population percent, which we calculate in Excel. So I haven't changed this yet. So all I'm fixing in this file is I'm using basket size. So I'm going to fix the basket size. To fix the basket size, what I did was basically I created a new calculated field. And that calculated field is basically order ID fixed sales. So let's look at this one. So the order ID fixed sales is a LOD expression with fixed at the order ID level. When I sum the sales, I do it always for each order ID before I do any calculations on this. Okay. So as soon as I do this, you notice my basket sizes will change. So I'm going to use that new variable. So it's very simple. All I'm doing is I'm just dragging this variable once I create it and use that instead of using, here I'm using the sales, here I'm using the order ID fixed sales. Okay, so relatively simple. Now, how about fixing the sales, total sales, total population. That's a bit more complicated. So, and I did that in this file. So analytical interaction examples fixed LOD state population. I went ahead and fixed it for all my tables. So now if you notice, if you open this file, in each one I'm using, so let's go ahead. So orders per state population, and so let me go ahead, state population. So let me see which one I'm using. So you notice I'm using the population 2018 here to calculate state population, and orders population here I'm using again the population percent, but let me see. All right, so here I'm using the count order ID and I'm fixing the count order ID, right? So I'm fixing it at the table level, okay? Right, so this changes the formulas a little bit, but nonetheless now I'm using level of detail expressions to calculate all of this. All right. So here are these example expressions. So what I do is when I do the count of order IDs per each state, okay, I basically count distinct order IDs, okay, and then subtract from this the max of the population percent. Okay, for each state I find the max of population percent, and then on the left side I count the order ID divided by the fixed count ID. Okay, so now it basically fixes at the table level. So when I then go ahead and remove certain states, it's going to actually keep it fixed. So what this will fix is the following. So if I go ahead and then go, let's say one of these where I have these states, if I remove, look at Florida number, I'm going to remove various states. You just notice this further number will stay the same. Why? Because I use the stable scope level. So I basically use the stable scope LOD expression. So remember, this was stable scope because I don't have any dimensions. Okay? So this kind of fixes all the problems that we had with these filters. Okay? I do the same thing for sum of sales, and exact same thing. I do it fixed, and I do it also for count order ID and then the difference between sales. Okay? For population percentages, I can fix it at the state level. So I can actually have the average population and fix it at the state level, and also fix it at the table level, right? And sum of the fixed states. So now what it will do is, regardless of what states I have in the field, it will always calculate it in this way. Okay? So this will give me the correct population percentages. I think I have it in one of these. I must have created it, but let's find out. All right. Right here, it's a population percent, so let's look at it. So this is our population percent using LOD expression. Okay. So now this value, you'll notice it's gonna stay the same. It's not gonna create that stupid. So if we go ahead and let's do it, let's create a brand new one so we can show it to you. So I go ahead and take the population 2018, okay, and put these states right here. Okay, let me put the states here. And go ahead and then do a table calculation and then make it percent of total. Remember, I get these weird numbers. Okay, so what I instead I can do is I can go ahead and add population percent LOD, right, and then add the state. So let me add the state in the, so where's my state? Right, I'm going to add the state here. You'll see these are going to be the correct populations because it's going to calculate with LOD, right? So it's not going to have those errors. Clearly, California doesn't have 44% of the US population, okay? So it's a bit complex, I know, but this is how this is going to be done, okay? So you fix it at the state level for that state, find the average of population of that state, and then you fix it at the table level for each of the states and sum them up. Okay, so now it basically fixes, you know, regardless of what you do, it's going to always calculate the right value for you. All right. Now this is all for about LOD expressions. I want you to please go ahead and watch the tutorials. I know these are a bit complex because I kind of got into this complex problem from the get-go, but they're relatively easy to use. A bit tricky to write, but overall it's not that hard to come up with a solution using LOD expressions. All right, this concludes our lecture. Next time I'm going to talk about time series data.